Hello and welcome late to Calculus in the PM. Take a minute to read about the definite integral. We're talking about adding rectangular strips, and right now we've begun our journey. We're using this function y equals 9x squared plus 1. Read through this. And we are currently calculating, using our calculator, the left side of each one of these rectangular strips. That's the height. The base is always decimal 1 in width. They're adding up the total area right now using a list from their calculator by adding it. We used our calculator table set function. Just a second here. Okay. It's easy to make an entry mistake on one of those, but I think you probably know what you're doing. 3.565 is what people were getting, and that is what I got. Now, let's examine this. I'm going to ask you something here. Would you say that this area, and I drew in all the blue and you drew in your strips, is this an underestimate or an overestimate? It's clearly an underestimate, because you're missing all these little gaps here, right? So, sometimes you'll be asked to justify what, is this an over or underestimate? And you could say a few things. Now, in this case, it's a left, we could say a left rectangular approximation on an increasing function. Any increasing function, do you see that you'd always get, even if it was concave down, and you were doing left, it still would be these strips, right? Would still be underestimates. If it's an increasing function, left approximations will give you a underestimate. So I want you to write this down even though it wasn't asked for. This area is an underestimate. Since we're on space, it's a left approximation on an increasing function. I guess this portion of, we don't know what the rest of the function, well, we do know this. There are portions of this function that is decreasing, right, on the left side of the axis on an increasing interval is a better way to say that. Now, does that make sense? I don't care how you draw it. If it's an increasing function, you do a left approximation, it's going to be an underestimate. Question or just a yes? Okay. Now, I'm not going to get you to do the RN, but it would use the same list. And what would the rectangles look like? Well, the RN, I go from the right side and make that my height. It's hard to draw that accurate here with this. This one here, this one up. My board is out on there for the, I'm going to just push this up a bit. And then go for it. Okay, that was really wonderful. But I think you get the idea. So if I use the right value on the strip, and you can just quickly sketch those in. I'm not going for neatness right now, it's just for learning. This would use almost all the same values, except you wouldn't use the value at 0 that you used for the left. You wouldn't use this one. And you would use this height here at the end, right? At 1.0. Now, I think it becomes very clear it's a overestimate, right? Now, and I think you could use analogous reasoning, right? It's an overestimate because it's a right approximation on an increasing function. If this was a decreasing function from left to right, it'd be an underestimate. If you can imagine a function going like this, and you did a right approximation, oh, it'd be an underestimate, and so on. So it depends if the function's increasing or decreasing. Lastly, MRAM, midpoint rectangular approximation method. Now, the first few strips won't look that accurate. I'll maybe start at the highest here. At the midpoint, boom. My strip was awful there, but you get the idea. Just draw those in. Approximate. We're not going to actually calculate, but you know how you could use your calculator to come up with this. I think. You do? I'm assuming you do. By the way, you choose the middle x value, not necessarily the middle height. There is a difference.
Do you know that those are disappearing after you?
Oh my goodness. And I know there's a glitch in this dang board on my computer software. It's actually not the board. Thanks for letting me know. Okay, anyways. You would expect this midpoint to be far more accurate than the other methods. Now, think about this. Is this an over or underestimate? You think it depends.
That's a medestimate.
A medestimate. Let me just get out of this quick.
Just a movie you're trying to ask.
And let me just think of something here. We'll have a different function in there altogether. Well, can you guys tell whether this is an over or underestimate? My back is still hurting. It's actually a herniated disc or something like this that just appeared. Anyways, it's gotten way better. Last 2 days I could barely walk. What do you guys think? Is this an over or underestimate? Because within one rectangle, now my drawing is really messy. Yours is, you think it's over the area? Well, the problem is like I said, I haven't got a very good drawing here. Now, if I really look hard for the midpoint, it's hard to tell here, but because it's concave up, curving up, there is a slight, this is far more accurate than either method, right? It kind of splits the difference. We added some area here, but we're missing this area here. And when it's curving up like that, though, does it make sense if I expand one of those strips here? Like this. And I say, now I've really overdone it here. Concave up. If this is about the midpoint right here, and I take this strip here, that's the stuff we're missing, but this is, this is the stuff we're missing on the right. The stuff on the left is the stuff we've added. Are we missing more than, or is this going to be, is this right here, is this an over or underestimate? It looks like an underestimate because the right-hand side of the strip is increasing even faster, right? That's the way it's concave up. When it's increasing and concave up, this will be an underestimate. But don't worry. If you draw one strip, and my drawings aren't that great, I can't be too accurate. I'm not very good with the smartboard when it comes to that. But if you just draw an explode view of one of the strips, you'll quickly see, and you can reason out, I guess I'll do a different color, that would be. Now my strip there wasn't that great, was it? Well, you would have missed out on more area. This is a slight underestimate, but it's far more accurate than the others. And that's because it's concave up. If it was concave down, as you went from left to right, but it was still increasing, it'd be an underestimate. Okay? Now, taking a look again, and I know time. So left, right, or left, midpoint, and right approximations to the areas of x squared from 0 to 3. You take a look at this picture here. And you can tell right away, again, it's an increasing function. So, again, this is below or under, right? This is definitely an over. And this is a pretty good approximation. It'll be slightly under though, right? How could you improve the accuracy of any of these three though? Oh, you could sort of average them all together, kind of. But I'm thinking make more strips. It would be more work to actually calculate though, right? But doesn't it make sense? The skinnier the strips, the less error in each strip. But you're not going to. And that's what I used to have. The last year I had people do with this calculator where you put it, 999 strips was the limit for the TI 84s. But we're not going to do this year, okay? Don't worry. All it is then an exercise. I think it's pretty common sense. If you have one strip, it's very inaccurate, right? If I did one strip for this whole thing between 0 and 3 and I said, I'll use a left approximation, well, that's extremely inaccurate, right? If I said now do a right approximation for one strip from 0 to 3, that'd be way over, right? Midpoint. And you can see how that would work too. Now, I'll just erase that. But that's, then you say, well, then if I used 1,000 strips, it'd be really accurate. Now, estimate, and I had them estimate using this, but here, I want to do this on your calculator. If you used 100 strips in this scenario, and we actually used the program, we got 5.77696989, and we used our calculator to verify that. Make sure your answer is the same. I'm going to tell you guys right now, there's a little secret here. But it doesn't matter anyways. And the last one, I am skipping this here, and I even wrote in my book, skip, regardless of whether we're using the calculator. But the whole idea was to do the area of this sphere by cutting it into like cylindrical strips. And obviously the more strips, if you have 10 slices, sort of accurate, but as you get to 1,000, you get to a highly accurate slice, was the whole point. We played around with our calculators and saw that. But and compared to the actual volume, 2.268 4/3 pi r cubed is actually what we know the volume of a sphere is. We could do that. However, I'm going to get you guys to turn to your textbooks right now. 270, or no, is it 273? And we'll just double check here. Oh, that's such a quick review. Actually, 274 is what you should turn to. 274 for the exercises. And some of these exercises don't even do anything with those things. I'll stop.